Grammarly does more than catch errors. With Grammarly, you can find really good, no, perfect words that make your writing sharp, or explicit, or excellent, or distinctive. As a matter of
In this lesson, we're going to focus on Newton's method for approximating zeros of a function. So let's say if we have this function, f of x, and it's equal to x cubed minus 4x squared plus 1. Now there could be at least 3 solutions to this equation. We're going to focus on finding just one of them. So we have to guess a value for x. We have to pick a value to start with. So let's see what the function value is when x is 0. So f of 0 is going to be 1. Now let's pick the next best number. Let's try 1. So this is going to be 1 to the third minus 4 times 1 squared plus 1. So that's 1 minus 4 plus 1. 1 minus 4 is negative 3 plus 1. This is negative 2. So going from 0 to 1, notice that the y value changes from positive to negative. And since this is a continuous function, at some point it had to cross 0. So one solution to this equation, that is, if we set it equal to 0, x has to be somewhere between 0 and 1. There's some value of x where y will equal 0. So let's solve this equation. So if x cubed minus 4x squared plus 1 is equal to 0, what is the value of x? So pick a number between 0 and 1. We're going to start with 0.5. That's going to be our first iteration. Now, using Newton's method, it helps you to calculate the next 0 given the first one. So x raised to the, or x sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. So using the first 0.5, this equation will help us to get a more accurate 0, or a more accurate solution to the equation. So if n is 1, n plus 1 is going to be 2. So we have this expression. So x2 is going to equal x1 minus, well, x1 is 0.5, and then minus f of 0.5 divided by f prime of 0.5. So let's figure out what f of 0.5 is. So this is going to be 0.5 raised to the third power minus 4 times 0.5 squared plus 1. So let's use a calculator for that. So this is equal to 0.125. Now we need to find the first derivative. The derivative of x cubed is 3x squared, and the derivative of 4x squared is 8x. So now with the first derivative, we need to plug in 0.5 as well. So this is going to be 3 times 0.5 squared minus 8 times 0.5. So this will give you negative 3.25. Now let's plug in everything into this equation. So f of 0.5, that's 0.125. And f prime of 0.5 is negative 3.25. So the two negative signs will cancel. So it's 0.5 plus 0.125 divided by 3.25. And so this will give us x2. And so that's going to be
তারা খেলো মৌকা দিয়ে টাইম টাইম খাওয়ানো দেখি শরীরের অবস্থাই নেই টাইম টাইম খেলো এই যদি সারাদিন প্রিয় থাকো দুটো ভাতও খাও না দুটো ভাত খেলো আর বারবার করতে থাকি দিঘা উঠছে নি দুটো ভাত খাইতে পর মায়ের থাকলে তো কত চিল্লাইছে কিন খেলো
5.385. So now we need to do another iteration. So I'm going to rewrite the first derivative here because we're going to use it again. So x3 is going to equal x2 minus f of x2 over f prime of x2. So x2 in this example is 0.5385. So let's evaluate the function at x2. So f of 0.5385, let's plug it in into this equation. So go ahead and type it in your calculator. Let's see what that's going to give us. 0.5385 raised to the third power minus 4 times 0.5385 squared plus 1. Make sure you type in everything correctly. If you make one mistake, the whole problem is ruined. So this is negative 0.003774. You might see it as 3.774 times 10 to the minus 3. It's the same. And now let's do the same for the first derivative. So we're going to plug it in to this equation. So it's going to be 3 times 0.5385 squared minus 8 times 0.5385. So you should get negative 3.4381. So now we can plug these values into that expression. So x3 is going to be 0.5385 minus, and then f of 0.5385, that's negative 0.003774. And then we need to divide that by negative 3.4381. Now, notice that this answer is close to 0. That means x, the solution that we're looking for, where the function has a y value of 0, is close to this number. So x3 shouldn't be too far away from x2. Now, these two negative signs will cancel. So overall, we'll still have a negative sign. So this is going to be 0.5385 minus 0.003774 divided by 3.4381. So you should get this answer, 0.5374, which is very close to x2. So chances are, because the answer is so close, that means that this is a good estimation. And let's check it. What we're going to do is plug it into this expression and see if we get an answer that's very, very close to 0. If we do, then we could say this is the solution to the equation, or at least it's one of the solutions. So let's evaluate f of 0.5374. Let's see if it's equal to 0. So go ahead and type that in to your calculator. So I got 5.4136 times 10 to the minus 6. So that's very small. That's basically 0.00000544136. So we could say that is approximately 0, which means the solution is 0.5374. That's one of the solutions to this equation. And so that's how you can use Newton's method to solve functions. You can approximate zeros of the function just by picking a value that's close to the actual 0. If the value is too far away, you may have some issues with Newton's method, but if you want to pick a number that's close to the actual 0 and use in multiple iterations with Newton's method, each time you do it, you're going to get an answer that's even closer to the real answer. So if you do it 2 or 3 times, it's usually good. And as you can see, we only had to do it 2 times for this example. So hopefully this gave you a better understanding of how to use Newton's method to solve zeros or find zeros of a function. So that's it for this video. Thanks again for watching, and have a good day.
इस लेक्चर में आपका स्वागत है। आज हम बात करेंगे रिचर्डसन एक्सट्रापोलेशन की। पिछले लेक्चर में हमने देखा कैसे हम न्यूमेरिकल डिफरेंशिएशन निकाल सकते हैं विद द हेल्प ऑफ डिस्क्रीट डाटा पॉइंट्स यूजिंग वेरियस डिफरेंस फॉर्मूलाज। और इसमें जो हम डेरिवेटिव निकालते थे वो हमने देखा था दो मेथड से, पहले स्ट्रेट लाइन के साथ इंटरपोलेट करके और दूसरा पॉलिनोमियल के साथ इंटरपोलेट करके। तो फ्रेंड्स देखिए, जब हम किसी फंक्शन को स्ट्रेट लाइन से इंटरपोलेट करते हैं तो उसमें कितना ज्यादा अप्रोक्सीमेशन होता है। सपोज कीजिए हमारे पास ये कर्व है और मेरे पास ये दो पॉइंट पर वैल्यू पता है, से दिस इज xi एंड दिस इज xi प्लस 1। तो अब जब मैं इसका डेरिवेटिव निकालूंगा तो फॉरवर्ड इंटरपोलेशन से निकाल सकता हूं। वो क्या होगा, f xi प्लस 1 माइनस f xi अपॉन xi प्लस 1 माइनस xi। तो जब यहाँ पर फंक्शन की वैल्यू देखेंगे ये आएगी इधर, दैट दिस इज अवर f xi, और इसके कोरस्पॉन्डिंग वैल्यू होगी कुछ यहाँ पर दिस इज एफ एक्स आई प्लस 1। अब देखिए मुझे इस पे डेरिवेटिव निकालना है, क्योंकि ये डिस्टेंस बहुत ज्यादा है तो ये डेरिवेटिव जो आएगा ये हाईली इनएक्यूरेट हो सकता है। ये कोई लाइन होगी जो यहां से पास करेगी, लेकिन जो इसकी एक्चुअल स्लोप है वो कुछ इस टाइप से होगी। तो आप देख सकते हैं कितना वेरी कर रहा है एक्चुअल रिजल्ट से हमारा अप्रोक्सीमेटेड रिजल्ट। तो इसी रिजल्ट को इंप्रूव करने के लिए अगर हम इस एच को स्मॉल करते चले जाएं तो ये रिजल्ट जो है वो इंप्रूव होता चला जाएगा। जैसे ही एच यहाँ पर आएगा ये स्लोप जो है ये चेंज होके ऐसे हो जाएगी, फिर और पास आएगा और स्ट्रेट हो जाएगी, तो धीरे धीरे एग्जैक्ट स्लोप से मैच कर जाएगी। सो आई कैन से दैट द एक्यूरेसी ऑफ मेथड्स for computing derivatives or integrals of a function, say fx, depends on the spacing between points at which f is evaluated। तो जो ये पॉइंट्स हैं जिन पे हम f को इवेल्युएट कर रहे हैं, f डैश x की एक्यूरेसी इन पॉइंट्स के बीच की स्पेसिंग पे डिपेंड करती है, एंड